Our names are
Sheng.
Sheridan Stewart.
and Austin Van Loon, and our project is titled A Sociologist and a Computer Scientist Walk into a Bar, Leveraging Affect Control Theory for Humor Detection. How can we use patterns in natural language and theories of human cognition to understand and automatically detect humor? Humor is one of the most complex forms of human language. Here we see various examples of so-called one-liners, which make use of various rhetorical devices to create the experience of humor in the reader. These jokes illustrate why the problem of humor detection has been difficult for computer scientists. This joke requires knowledge about a cultural product, while this joke requires rudimentary understanding of German. There are two theories of humor we plan to leverage for our project. Ambiguity theory, which posits that humor arises from ambiguity in communicative acts, and incongruity theory, which posits that humor arises from the breaking of expectations, whether they be broadly cultural expectations or expectations created within the posited scenario of a joke.
Here we present some of the previous literature on humor detection. Mahalsia and Straparava pioneer supervised learning methods to detect humorous one-liners. Taylor uses a novel approach she calls ontological semantics to approach the problem. Other scholars have used unsupervised methods,
while others have attempted to incorporate outside knowledge, such as Wikipedia page content, into supervised learning models. The paper we see is most closely related to what we're trying to accomplish with our project is Yang et al. They model 4 different latent structures of humor: ambiguity, incongruity, interpersonal affect, and phonetic style. Here, we're just going to focus on ambiguity and incongruity. They model ambiguity with sense combinations and path similarities. They model incongruity with distances in glove space.
Affect control theory is a social psychological theory which in part posits that individuals are motivated by deflection or cognitive dissonance to reconstruct situations so that they are more or less in line with their cultural expectations. Theorists measure and think about the affective meaning of concepts as being in a three-dimensional EPA space.
When a situation combines an actor, say, the mother, and an object, say, the baby, with an unexpected action, such as dropped, it causes deflection or cognitive dissonance. So the perceiver is likely to reconceptualize the situation in a way that is less unexpected. We think that considering knowledge from these 3 domains will allow us to better understand humor and create good classifiers. We find this approach leads us to what we see as a novel understanding of one-liners, which we discuss in depth in our paper.
To test this approach, we use standard data as well as novel data scraped from various subreddits. We have about 19,500 examples in this compiled dataset. We task ourselves with identifying text that is meant to be humorous from text that is not. Since our approach is theoretical, we decide that the F1 score makes the most sense for us.
We set up 3 baselines: stupid baselines, which we expect to outperform, smart baselines, which we expect to be outperformed by, and competitive baselines, which we hope to outperform. Here we present some of our preliminary results. Here you see our so-called stupid baselines perform better than one might expect. Our bidirectional LSTM, as expected, performs very well, with an accuracy of about 0.89 after 10 epochs. Going forward, we plan to implement our competitive baseline as well as our theoretically informed model, compare the results, and use this to further our knowledge of affect control theory, humor, and the task of humor detection. Thank you so much for your time.